our area governor, and he's going to be giving a little speech for us tonight. It's called, I had it on me, being in the from the advanced manual, technical presentations. It's number 3 in the series. The objective of this speech is to interpret technology to an audience that lacks technical training. He's going to be talking about Aurora Borealis. It's one of the 7 natural wonders of the world along the Grand Canyon and the Great Barrier Reef. Mankind has marveled at these fantastic displays of light for millennia. Listen carefully as Mark explains how these lights are created. He has a PowerPoint presentation for us as well. If you have a question at any time, raise your hand and he'll answer it. This is going to be this timer for 8 to 10 minutes. It is my honor to introduce Mark Richards.
Toastmaster, fellow Toastmasters, and honored guests. Go ahead. We have no remote for the so sometimes they're called the Northern Lights, but actually they're also called the Southern Lights because they happen not only in the north, near the North Pole, but also by the South Pole. So we are going to, go ahead, we are going to investigate how this works. And let me start by saying that this is what they look like if you've never seen them. Go ahead. These are random pictures that I got off of the internet. They're beautiful, mostly waving columns or spirals of light, sometimes gaseous. Sometimes the lights are purple, sometimes the lights are yellow, green, and I'll explain why they have the different colors in just a moment. Now, the sun is the source of all the energy that we know. Coming out of the sun are waves. These waves are made up of disturbed electrons. They leave the sun at the speed of light. Okay. As they approach the Earth, 93 million miles away, the Earth has a giant magnetic column or sphere around it that deflects most of the light of these electrons. However, because the magnetic sphere around the Earth is weaker at the North and the South poles, the electrons can actually come into the atmosphere. What happens next is that the electrons, as they enter the Earth's atmosphere, they interfere with gas molecules. When they hit gas molecules of different types of gas, they let off photons. Photons are light. If an electron hits an oxygen atom, for example, the light will be yellow-green. If it hits an argon or a nitrogen atom molecule, then they will be a different color, and it depends. Oxygen being the most prevalent, yellow-green is the most prevalent color for the Aurora Borealis. By the way, in the south, it's not called an Aurora Borealis, it's called an Aurora Australis. Anybody has any questions, by the way, please ask. This is an example of a very proud and bright, shimmering light. The Aurora Borealis, the lights themselves started anywhere from 6 miles and go up to as high as 200 miles in the So even though you might not, when you're looking at them, you can't tell how high they are, sometimes they can be huge columns of light, and they might be farther away. The best places to view them are in northern Canada, parts of Alaska, Siberia, sometimes Greenland, and in the south, Antarctica, and sometimes Australia, and the south of South America. Sometimes in South Africa they see them, but not as often. They actually don't form, the holes in the Earth's magnetic sphere are not actually circles. They're more of a, they change constantly. The reason that the Earth has this magnetic field is because the core of the Earth is spinning. It's liquid and it's spinning, and it creates this magnet around the Earth. So there you have the basics of how the northern lights are created, I have a bucket list. I want to see that in person. It's said to be, take your breath away, mind-boggling, fantastic. In the ancient times, as was mentioned in the introduction, millennia ago, people wondered where they came from. Some people thought they were the spirits of deceased relatives. Some thought they were animals that had gone on to heaven, or they were spirits that were trying to come down and become corporeal. So there were lots of myths because they didn't know the science. It wasn't until the 1800s that when the first telescopes first allowed us to see the sun and the sunspots, they theorized that every time there was a sunspot, which is a huge ejection of solar electrons, that the Aurora Borealis got more powerful. And they put the two and two together, and these theories started becoming a very powerful way to study the sun. And not too long ago, we just had our first sun exploring mission launch. They're actually sending a spacecraft to explore Mercury and then the sun. They will confirm a lot of the theories that we've had all these years about not only solar sunspots, but about Aurora Borealis and where we get some of our weather from. Are there any questions? Yes?
I didn't catch whether you said this or not. I actually saw this YouTube this week, ironically, on this and watched about 20 minutes. It was awesome. And but I didn't catch whether why do they only show up in specific certain places over and over again?
Can you go backwards? You may not be able to do with that. You don't have the controls, never mind. The reason is because of the magnetic sphere. Earth has a, one more. Okay, there's the Earth, and on the left you see the Earth, but around it is this giant magnetic field. It's as if you had, if you took a magnet, no one knows, you look at a magnet and say, it's a piece of metal. But you take another magnet, you put it next to it, and either it's going to clamp together, or if you turn it to the opposite side, it's going to repel. So there's some force there that no one can see. Electromagnetism is unbelievable. Well, what happens is, because the core of the Earth is spinning at a separate rate from the rest of the Earth, it creates a magnet, a magnetic field around the entire Earth. And the only way you can see it is from space, really. And they've used space telescopes to look at the Earth in certain frequencies. And they can tell that it looks something like the picture on the left, on the right. What happens is, as the electrons are coming from the sun, they bounce off and are deflected by the Earth's magnetic field, which is why we're still living. Because if the Earth didn't have a magnetic field, if the core was not moving, we would never have risen as a species. No life would have existed on Earth. So what happens is, as these electrons are heading towards Earth, they are deflected around most of the Earth, but they can come in through the weakest points, which are the north and south poles, because it is as it shows in that picture, they are deflected around, but these weak points right here, the electrons can go in. When they hit the Earth's atmosphere, that's when they interact with the gas molecules and create the lights. And they shimmer just like, if you've ever seen heat from a distance over a desert, for instance, you see it shimmering. That's the actual waves, the wavelength of light fluctuating. Same thing happens with the Aurora Borealis. Any other questions? Yes?
You mentioned that wavelength, the mirage effect?
Yes, mirage effect. And that's basically why the Aurora Borealis moves. These lights don't just sit there. Because not only are they encountering air, which has a lot of turbulence in it, the electrons are not coming at a steady rate. So they're coming at varying rates by themselves. They're hitting the air, which has turbulence in it. And so as the photons are ejected from the gas molecule interactions, they shimmer. And also, again, because of the different types of gas molecules, they can change their color. Mr. Toastmaster.